Hello everybody and welcome to the first Silvera tutorial. In this tutorial we're going to demonstrate the basic functionality of the Silvera. So first let me say what Silvera actually is. Silvera is a tool for describing distributed systems based on microservices, and for that purpose we're going to model a small bookstore web shop application. So let's begin. First thing you want to do is you want to create a virtual environment where we will install the tool. Okay, so let me just activate it and let's install Silvera. Okay, so I'm just going to verify if everything is installed correctly by calling Silvera in terminal. Okay, so if you get this output here, then it means everything works correctly. So let's create our project. So I'm going to type Silvera init, and here I need to name my project, and I'm going to call it bookstore. Alright, so as you can see, we have folder called bookstore, and if I go inside we will see that there's setup.si file. That file contains definition of configuration server and service registry, so it can help you a bit to start quicker. So let me just open this folder in Visual Studio Code because it will be easier for me to type. First microservice that we are going to define in this tutorial is user microservice. So here's how we do that in Silvera. We're going to type service and let's call it user. We want to make sure that this microservice is registered within service registry that we defined in setup.si, this one here. So we type service registry and provide it with the reference to the already defined service registry. Okay, let me just save this. Okay, so microservices can communicate via various mechanisms. So in this tutorial we're going to use RPC as our communication style. Okay, so once we've done that, we can proceed to define an API for our microservice. Here we can define domain objects and methods that can be used. So to define domain objects we use type def, and let's call it user, and our user domain object will have following attributes. Let's say we have username, we have password, and we have email. Alright, so for every type def we can automatically generate CRUD methods by adding simple CRUD annotation on top of the type def. Also, for each of the attributes Silvera has special annotations such as ID or required or sorted and stuff like that. So let's make our username attribute an ID, and also let's make sure that password and emails are required fields. Okay, so now that we define this attribute, we can define some of the functions also. So for example, we can define a function that will return a list of all users in the database. Let's call it list users, and let's make sure that this can be accessed by HTTP GET method via REST. Also, let's define a function that will check if the user exists, and this function will have ID as an argument. So in our case ID is username, and also let's make sure that this function is also available via HTTP GET. And let's add a function that will return user's email. So user email. Okay, and also let's make sure it's a HTTP GET method. And that's it. We defined our user microservice, but also we need to import setup SI because we are using an object service registry that is defined in this module here. Okay, so next module we're going to define is bookstore, right? Okay, so just a second. Let's create new module called bookstore.si, and let's immediately import setup SI. Okay, so we will define a service called bookstore, and also let's make sure it's registered within the service registry. Communication style is also RPC, and let's define API. Okay, so for this microservice we're going to define book as the main object, and let's have ISBN and maybe title, maybe also author, category for example, and let's say price. We'll make ISBN and ID, and let's make sure that the rest of the fields are also required. For the sake of it, we can just leave category as optional, so we will provide no annotation, and in this case for the price we're going to make it required. So let's also make sure that Silvera compiler generates CRUD methods automatically, and we can also define some functions, some additional functions like list books that will return a list of all books that we have in our database. Method is get. What I forgot to say is you can also, in this annotation, you can also provide a default mapping for this function. So for example, we can have list as mapping, which means that user will call this function like this. So we will have this URL, for example, localhost, if it's in local, then we'll have port, and then we'll have list. But if this here is omitted, if we provide no mapping, then mapping by default will be based on the name of the function. For example, in this case it will be list books, but with no capital letters. Okay, so let's just then remove this, and also we can define a function that will check if the book exists in the database. So it'll be bool book exists, and let's provide ISBN since that's our ID, and also we can, for example, return the price of the book. So book price, and let's say ISB. Okay, so we defined our bookstore microservice, and now we're going to define an order microservice. So order microservice depends on user and bookstore, and we will see how. So let's import setup SI first, and let's define order microservice. Service registry is service registry, okay. Communication style is RPC, and let's then define our API. Let me just save this. Okay, so here we're going to have order, and orders can be made by users, right? And also we can have multiple items in one order. So let's define another object. I'm going to call it order item, and since we are ordering books, order item will give us a book ID, for example, and let's say an amount of books that are ordered. So let's say, okay, like this. So we have book ID and we have the amount. For example, we can have multiple books in one order with the same ID. And also let's make sure that we define this here. So it's order item. Let's call it items. Alright, so let's define this. Okay, so Silvera compiler will generate CRUD methods for this, but for this one there's no need. Okay, let's make sure that this one is required, and also this one, because we want to make sure that order have both users, so we don't want to have some empty user fields or empty item fields. Okay, so since, as you probably noticed, we don't have an ID attribute here, nowhere, it will be created automatically. So let's define one function also. It will make our debugging easier. So this function here will list all orders that we have. Okay, so as you can see, in order to create an order we need user and we need book ID. Both of these are provided by user microservice and bookstore microservice respectively. So we need to define dependency between order microservice and user in order to get user, right? And we also need dependency from order to bookstore in order to check whether the book with this ID exists, and also to calculate, right, the price. Oh, I forgot the price. We need price. Okay, yeah, every order has one, right? Okay, so in this case we're going to define so we define dependency between these two microservices, but also we can say which exact functions are actually needed by the order. In our case, we're going to need user exists, right? Because when we create the order, we want to make sure that the user that is provided actually exists. So let's type user exists, and for the bookstore it'll be like book exists, right? Okay, since we also need a price for our order and each book has price, we need to calculate the price of the order, right? So we also need book price, right? These two functions. Okay, so book price, book exists. Also, to make everything work, we need to import user si and import bookstore si. Okay, so what would happen if user microservice is down for some reason? In this case, once the order calls order exists, if the user is down, then we will have some exception on the order microservice, right? But we can mitigate that by using circuit breaker pattern. So here we will define what happens if the user is missing. And there are several strategies that you can use with Silvera, and you can check documentation for more detailed info. But in this case, I'm going to say if the user service is not available for some reason, I'm going to use default values for this method. Okay, so I'm going to use the same thing here in book exist and book price. Okay. Also, let's say, since I already have user email here, let's also add this one as dependency. And also we can use fallback static. But okay, so this one can be tricky. So we have actually no default value for the email, but I'm going to use fail silent. So in this case, if user does not exist, order will also fail because it will report an exception in the client API. Okay, so we defined our microservices, and we can now compile them and transform them into runnable Java code. To compile our microservices, we're going to call Silvera compile command. And let's provide it with the path to our project. Okay, so compilation is finished successfully, but as you can see, we have some warnings. It says that fail silent returns default value, and this is in our current implementation. So actually it should return empty response, but in this version of Silvera it will return default value. Okay, so let's see how our generated code looks like. So in the output folder you can see all these projects that are generated from our descriptions. So if we go to the bookstore, we will see a typical Java application where we have controller, we have domain objects, we have repository, and we have service. It is worth noting that if we recompile this service, every change in this file in bookstore service will be kept. So none of this will be deleted. And that's the only file actually that won't be deleted and created again in case of compilation. So let's try to implement these functions. Also, as you can see, CRUD methods are provided with the implementation already, and the functions that we added here actually are the only ones that need to be implemented. So for example, list book will throw exception that it's not implemented if it's called, and let's add it with some basic implementation. So in our case, we're going to return all books from the database. Okay, so we are using MongoDB here, and our book repository extends Mongo repository, so all these actually repository functions are also implemented in advance, so there's no need to implement them manually. Okay, so what we're going to do next is implement the rest of the methods. So what we need now is to check whether the book exists. So we can use optional and say book equals, and here we can use book repository and find by ID method, and our ID is ISBN, so we can just say this is present. So if the book with the given ISBN is present in the database, then this here will return true, otherwise it will return false. And also we need price, right, for the book. So here we can use already existing read book method, and let's say book is read book with the ISBN as the attribute. And if the book does not exist, then this method will throw an exception. Okay, so, and once we get the book, we can just return the price. And that's it. What we need to do is then provide the implementation for the rest of the microservices too. And I'm going to skip that part for the user, but I'm going to just show you how to use how to implement service for the order, since order is a bit more complex and it also involves calling user and bookstore services to get some information from them. So as you can see, also CRUD methods are actually already defined, and all we need to do is define list orders, right? So let's just return find all. Okay, but as we said previously, we want to have order that it's valid, that has all users that are existing, and also that we also have books that are existing in a bookstore. So we need to define a function where we will validate the data. So I'm going to call this one check and update, and its argument is order. Okay, so right now I'm going to use user client to check whether the user in the order already exists in the database. So I'm going to say user client, and as you can see, let me just show you here, user client has user exists and user email functions that are defined here as dependencies. Okay, so let's go back to the service, and I'm going to say user exists and order get user, right? Because we defined user here, so we will have get user method. So in case this is not true, we are going to throw new, let's say, illegal argument exception and say user with username, and let's okay, user with username, and this that we provided does not exist. Okay. Okay, what's next? Well, we need to check if all these RDs are correct. So to do that, we can iterate through order items and say item. Okay. And order get items, right? And here we can use the same logic as above. So instead user client, we're going to call bookstore client, and let's say we can use book exists method, right? And we can say item get book, I think it's get book ID. Let me just check here. Yeah, it's book ID. Probably makes no sense because we defined ISBN here, but okay, never mind. Let me just copy this so I don't have to rewrite everything. And let's say book with ISBN. Here we can say item get book ID. Get book ID does not exist. Okay, so but if it does exist, we need to calculate the price of the order. So let's say initial price is 0, and here we can say price plus equals bookstore client, right? Book price, item get book ID, right? But also multiplied with item get amount, because we have an amount for certain amount for each book. I think I misspelled this one. Get amount. Okay, so that'll be it. And what we need to do is we need to just update the order with price, right? Order set price. So that should be it. What we will do now, we will just run these and see if these work. Actually, before we run these microservices, generated microservices, we need to call this method here. So I'm going to call it here before we save the order, and also here before we update it. So let me just copy this here, and we're going to use order update for this instance. Okay, so now we can run these and see how it works. So to run them, we're going to go to the bookstore output, and let's first start service registry. So run script is already generated for you. All you need to do is to run it, and we're going to do the same for our services. So since we have 3 of them, I'm going to need 3 windows. So let's start user, and also bookstore. Okay, as you can see, user is built successfully, sorry. And also bookstore, so let's then run the order. Oh. Okay, in case you get this exception here, that just means that a MongoDB service is not running on your computer, and all you can do right now is to just run it. System start. I am using Arch Linux, so it's probably the same for other variations of Linux. Okay, so now it is running, and let's rerun these 2 just to make sure that it won't interfere with how our services work. So we were in the order, and let's run script for starting and building. Okay, so we have some errors in our code, so let me just check it. And yeah, I'm missing semicolons here and here. Okay, so it should work now. Sorry for this. I haven't used Java for a while. I'm more of a Python kind of guy, so a few bugs later, we have a running service, which is good. And now let's see how we can interact with our microservices. First, what we're going to do is we're going to see where the services are registered, which ports they use. So I accessed Eureka with using this URL, which we defined, if you remember, here in setup SI. That was default value for the port. So as you can see here, we have bookstore, we have order, and we have user, and we have ports that they are using on the right side. So to access these services or to call their methods, I am using REST client login from Firefox. So what I'm going to do now is I'm going to list all the users that are currently available in the database. So I'm going to type, okay, so I have actually that method already. Okay, so if I call list users, you will see that I got an empty list, which means that currently I have no users in my database. So let's create one. So how we are going to do that? We're going to send post request on user with body, and also let's make sure that content type is selected as application JSON. So let's go back to the user service and see what attributes it contains. So we have username, password, and email. Okay, so let's add username, for example user1, then we have password, let's say it's pass, and email, which is, let's say, user@gmail.com, for example. So let's send request and see what will happen. Okay, so as a response we got serialized version of the user, and you can see that we get status code 200, which means everything works okay. So if I go to get and I list users again, I should get the list with yes. Okay, so now let's see if we can add a book. So bookstore is, okay, we just need at this port right here. Let me just, okay, and let's call list books. This here will be ignored since it's get request, right? So let's send it, and we also get empty response. So because we don't have any books in our database, so let's add one. Okay, so I'm going to send post request on book, and here's why I'm doing this, because we defined, in case of user, we define CRUD operations on the user type def, and this here, the name of the type def is used as URL mapping for the HTTP methods. So in this case we have books, and for user we had /user. Okay, so we need to add book. Let me just check the attributes again. Okay, so we have ISBN, title, author, category, and price. I'm going to just, okay, we have ISBN. I'm going to put some random value, title, which will be book A, for example, then author, which can be, let's say, author 1, or A is better. Then category, if it's fiction, let's say. We will have price also. Let's say this book is 20, let's say, euros, or whatever the currency is. Okay, so we have ISBN, title, author, category, and price. Let's see if this will work. Okay, so the request was being processed successfully, and let's try to retrieve this book here. I'll say 1, 2, 3, 4, because this is the key, ISBN is the key, and if we get the same thing here. So let's create an order. An order is at this here port, so I'm going to copy that, and actually I don't have to because I can just change it here and create order. I'm going to use post as a method, and here we have user and we have items. Okay, so let me just delete this quickly. Okay, we have items, which is a list of item orders, and each item order has book ID. Let's say we want to buy the book that we have in our database, and as amount let's put 2 books. And also we need to make sure that our user here actually exists, and I'm going to put user1. Okay, so this should work, I guess, and it does. And as you can see, we got our order successfully created with the price that was calculated based on the book and the amount. Book price and the amount. As you can see, remembering all these URLs and ports can be a bit cumbersome. So in order to mitigate this, we are going to introduce an API gateway, which will provide a single entry point for a user into our system. So let's define it. So this is how we're going to define API gateway in Silvera. We just type api.gateway, and we provide a name for it. We can say it's entry gateway. Okay, so we are going to register this gateway also to the service registry. Which means we need to import setup si immediately. Okay. Then also we can define how this gateway will be deployed. So we can say deployment, and let's say the version of our gateway is 0.01 and port is, let's say, 9095 with the URL that is, for this example, let's use localhost. Okay, so now we need to define how this gateway will communicate. So there's only one way currently in Silvera, and that is RPC. Okay, and now we define how we are going to route messages for our services. So let's say gateway 4, and now we say user, because this is the name of microservice, right? It's user microservice, user as, and then let's say URL would be like API/u. And for example, for bookstore, we can say API/b, and order as API/o. Okay, so I'm going to save this as gateway.si, and we also need to import modules for our services. So we have user si, we have bookstore si, and order si. Okay, let's save this and let's recompile. So I'm going to stop all these services right now violently, and let's recompile. Okay, so I can type Silvera compile dot, because I am already in the bookstore, and let's compile. Sorry about that. Seems like my Visual Studio Code plugin, history plugin, was creating some problems. Okay, so let me compile again. And okay, so compilation finished successfully. Okay, so let's go to the code again, and as you can see, we have this entry gateway now generated, and let's start everything from scratch. So I'm going to need another tab. Okay, so let's go to the output and service registry. Okay, so let's run. Even though I recompiled the model, all changes in user service should stay without changes. So let's try again. And now I'm going to go to entry gateway also here, and let's run it. As you can see, this can take some time, so we just have to be patient. Okay, it seems like everything is running again, so let's just reload the page, and you can see entry gateway here. So right now we just need to remember one URL point, and that's it. So let's try to list users. So we need to go /API/u/list users, and we need get method for that, and it works. We can also try to add new user to the database. Okay, so its username is user2, password. Okay, let me just delete this here, and I'm not going to put the safest password around, but it should be enough to demonstrate how this works. And let's say user2 at gmail.com. Okay, so let's try to add user. Okay, it seems to work, and let's just try list again. Well, it seems to be working. So thank you for watching, and this was all from the first video on Silvera, and we just demonstrated some basics that can help you with building your own microservices. Bye.